These examples tie into the Lewis structure worksheet that you've already received in class. We're going to do one sample problem at a time so you can follow along, complete the problem, and then go ahead and move on to the next one. I'm not going to complete every problem on the worksheet. You are going to be responsible for some, but this should give you a very good indication of what you should be doing and help you along. So what we're going to do is draw dot structures. You're always going to be given the formula, as you see here. So you're going to know what atoms you have to show and how many of each atom. It is going to be your job to figure out what the arrangement of these atoms are. So to help you along, there's some math you can do to aid you in figuring out what the structure should be. So we're going to use the same strategy each time, the same math, the same work each time. So we're going to start by writing the symbols of the formulas. And notice I'm including that H4 subscript. It's very important that you include subscripts when you write the elements down. Because what's going to happen is you're going to have to multiply the number of valence electrons by those subscripts. Another thing that might help is writing on the left-hand side what column or group the element is in, because that is going to determine how many valence electrons it has. So right there I have that silicon is in group 4A, and hydrogen is in group 1A, and really that just comes from looking at the periodic table. There's going to be two things you're going to total up. I'm going to write a V and a P. The V is for valence electrons, and the way you figure out the valence electrons is simply by the group number. So if I look at silicon in group 4A, I know that silicon is going to have 4 valence electrons. If I look at hydrogen in group 1A, it's going to have 1 valence electron, but this subscript means that there are 4 hydrogens, each bringing a valence electron. So because of that, you're always going to take the number of valence from the column and multiply by the subscript that's shown. Since silicon just has a subscript of 1, you just keep it as 4. And then to get the total number of valence, you're going to add 4 plus 4 to get 8. I'm going to box that off. What that means is that is the actual number of valence electrons. That is the number of valence electrons that has to be shown in your structure. The P stands for probable. It's kind of like actual versus theoretical when we do percent error. The probable number of electrons is going to come from the front of the worksheet. There's that chart. So you're going to use the periodic table to figure out the number of valence and the chart to figure out the number of probable. So I'm going to do again is figure out silicons in 4A. I'm going to go across just looking at the number of electrons used, not the bonds. And I find that any 4A element is probable to use 8 electrons, and any 1A element is probable to use 2 electrons. Again, same thing, you multiply by the subscript. Silicon just has a subscript of 1, so it is just 8. Hydrogen has a subscript of 4, so now that is 8. And to get the total number of probable, you add 8 plus 8 to get 16. Notice I do not box that off. So this is the actual number of valence, and this is the probable number of valence electrons. To figure out the number of bonds that are most likely to form, you take the probable minus the actual to get 8. And then I'm going to divide by 2 because every bond is made up of 2 electrons. So to get that, you're going to get 4. So what I've just figured out with this math is a probable number of bonds to show in my picture. Not absolute, not exact, not guaranteed, but a very good indication of what my picture should look like. After you figure that out, the last thing to figure out is which one is central, which one's in the middle. The way you do that is which one is closest to carbon. And obviously silicon is closest to carbon. It's right underneath it. So silicon is in my center. I write it in the middle. I then figure out the most logical way to combine 4 hydrogen atoms with 4 bonds. And the way to do that would simply be to put them around the silicon in like a cross shape, so that way they're even, and for it to be all single lines, which means all single bonds. Then you have to do your checks, I call them. You have to figure out, am I showing the right number of atoms? Am I showing 1 silicon and 4 hydrogens? Yes, I am. You cannot add or subtract atoms. Am I showing 4 bonds like I predicted? Yes. Last thing, you have to show the actual number of valence electrons in your structure. Remember that each bond, each line represents 2. So if I count the lines, there are 2, 4, 6, 8 electrons shown. I'm done, and there's my structure for SiH4.